Today, I am going on a hike in a national park. Let's see, do I have everything that I need? Right now, it is warm and sunny outside, so I will need some sunscreen and probably a hat. I will definitely need some water and some snacks too. Do I need anything else? I better check the latest weather forecast just to be sure. Uh-oh. It looks like it might rain later this afternoon. I better pack an umbrella just in case. Isn't it amazing how a day can start out warm and sunny and end up cloudy and rainy? Weather changes so quickly. What is weather? The weather is an important part of our lives. It determines what I pack in my bag today. Some days I might even have to change my plans because of the weather. We talk a lot about the weather, but do we really know exactly what weather is? Weather is the condition of the outside air or atmosphere at a particular time and place. Weather is what is happening outside right now. My weather is warm and sunny, but where you live, it could be different. Maybe you have sunnier skies, clouds, rain, or even snow. Weather is local. It is the conditions where you are right at this moment, and it can change quickly. Weather depends on several elements. The first is air temperature, or how hot or cold the air is. The second factor is humidity, or how much moisture or water is in the air. Some places are humid or muggy, while others are dry. A tropical island is likely to be humid, while a desert will be dry. The next element of weather is clouds. The amount of clouds and their condition affects the weather. Are the clouds white and fluffy, or are they dark, threatening storm clouds? Another weather element is wind. Wind is the speed of the air around you. Air pressure is another weather element. Air pressure refers to how much air is pushing down on the Earth's surface. The amount of air pressure depends on the height of a location and the temperature of the air. Let's look at two elements of weather and how quickly they can change. Right now, it is sunny outside. But what elements of weather might change as I make my way up the mountain at the national park? Even though the sun will be shining during my entire hike, the temperature is likely to change. That's because as I climb to a higher altitude or elevation, the air will become cooler. The mountain that I'm going to climb is not all that high, so I won't really feel the difference in temperature much. But if I were going to climb Mount Everest, I would really feel those frigid temperatures because of the mountain's high altitude. The higher you go, the colder it gets. The other change in weather that I might experience on my hike is an increase in winds. Remember that as I climb, the air will get cooler. Cool air is heavier than warm air. Cool air sinks, and as it does, it gets warmer. This warmer air rises back up again to start the cycle over. This cycle of sinking and rising air is what causes wind. So, as I climb to higher altitudes, the cooler, heavier air sinks faster, which creates faster winds. Thinking about cooler air and gusty winds is making me realize that I should probably pack a sweatshirt. Right now, it is a hot, sunny day, but the weather forecast is calling for possible showers later on. How will these showers come about? Well, the hot air temperature means that moisture or water is evaporating into the air. This hot air rises, and as it does, it starts to cool off. The moisture in the air turns back into droplets of water. When this happens, clouds form. Rain occurs when water droplets in the clouds get heavy enough and begin to fall to the ground. Rain is one form of precipitation. Precipitation is water that falls from the sky. Another form of precipitation is sleet. Sleet occurs when ice crystals fall from clouds and melt as they reach warmer air, and then refreeze as they get closer to the ground. So, weather is the current condition of the Earth's atmosphere in a particular location, and it is constantly changing. Weather can change in a matter of minutes, so that's why it is probably a good idea for me to pack a sweatshirt and some rain gear. To help us plan, we rely on weather forecasts that are prepared by meteorologists. A meteorologist is a person who studies weather patterns in an attempt to predict future weather. Meteorologists have a difficult job because they must look at all of the factors that influence weather, like temperature, winds, and air pressure. A weather forecast is never certain. It's always a probability. In other words, meteorologists use computer weather models to predict what the weather in a certain place might look like. Let's review what we have learned about weather. Question 1. What do we call all forms of water that fall from the sky? A. Monsoons. B. Precipitation. C. Clouds. D. None of the above. The correct answer is B. Precipitation is water that falls from the sky. Question 2. What do we call the level of moisture present in the air? A. Air pressure. B. Wind. C. Humidity. D. Rain. If you answered C, you know that humidity is the amount of moisture in the air. Here's question 3. What happens to air temperature as you climb to higher altitudes? A. Air temperatures get cooler. B. Air temperatures get warmer. C. There is no change in air temperature. D. Air temperatures get cooler, then quickly rise. The correct answer is A. Air temperatures get cooler as you climb higher. What is climate?
And this low pressure system is going to slide in.
Meteorologists try to help us know how to prepare for the weather we will be experiencing this week. They study recent weather patterns for particular areas. They use these patterns along with current conditions to come up with a short-term weather forecast. Oftentimes, we hear people talking about weather and climate. Are they the same thing? No. Climate is the weather patterns of a region over a long period of time.
The difference between weather and climate, which is important to note, is that weather is sort of like our mood, how we feel on a day-to-day basis, whereas climate is like our personality over time. You know, sort of like, do we bring an umbrella today or do we bring it this season?
Climatologists look for the big picture by looking at weather patterns that go back 30 years or more. So, while a meteorologist looks at the current weather, a climatologist looks at the average kind of weather for a region over many years. Both climate and weather measure the same things like temperature, winds, and precipitation. But weather measures these factors in the short term, while climate measures them over the long term. Today's weather is only one piece of your area's overall climate puzzle. The Earth is divided into 3 major climate zones. The polar zones, near the North and South Poles, the middle part of the globe, known as the temperate zone, and a southern zone, known as the tropical zone. Climate zones explain the weather patterns and plant and animal life that are present in different areas of the world. The climate of the polar zones makes it possible for polar bears to survive, while birds like toucans thrive in the tropical zone. Climate is determined by altitude. Again, the higher you are, the colder the climate is. A city at sea level will have a warmer, moderate climate, while Mount Everest will have an extremely cold climate. A region's climate is also affected by its latitude. The closer the area is to the equator, the warmer it is. Geography or landforms also affect a region's climate. Places near a large body of water have higher humidity and more moderate temperatures, while desert areas have very low humidity and much higher temperatures. It is the interaction of these factors over long periods of time that determine a region's climate. Think of it like this. Climate is what you expect, while weather is what you get. One thing that climate data or statistics can tell us is the maximum and minimum temperatures for a region. Suppose you are going to visit New York City in August. Can you use past climate data to give you an idea of what to expect? Yes. You could ask yourself, will it be hotter than 120 degrees? Probably not. Climate data shows that for the past 100 years, the hottest New York City August days reached temperatures right around 100 degrees. Is it likely that your August days in New York City will be colder than 30 degrees below zero? Climate data over the past 100 years says no. 2007 and 2011 saw the two coldest August days at 59 degrees. So, climate data would allow you to see that over a long period of time, New York City has temperate, warm temperatures in August. But, while knowing the climate of New York City tells you that you will not need a parka in August, it will not tell you whether or not you need an umbrella as you tour the city. That's because weather is local and temporary. Now we know that weather and climate are two different things. Let's review. Question 1. What do we call scientists who look at weather patterns over long periods of time? A. Forecasters. B. Meteorologists. C. Climatologists. D. Botanists. The correct answer is C. Climatologists study weather patterns over long periods of time. Question 2. The Earth is divided into how many major climate zones? A. 2. B. 3. C. 5. D. 7. If you answered B, you know that there are 3 major climate zones. Question 3. What type of climate are desert areas likely to have? A. Dry and hot. B. Warm and humid. C. Dry and cold. D. None of the above. The correct answer is A. Desert areas tend to have dry and hot climates. What is the greenhouse effect? Climatologists and other scientists are concerned. Climate data for our Earth tells us that the global air temperatures near the Earth's surface have been rising. 11 of the past 12 years have been the warmest on record. They also report a rise in the air temperature of almost 1.5 degrees Fahrenheit over the past 100 years. 1.5 degrees may not seem like a big deal, but when it comes to the delicate ecosystems of our Earth, this small increase in temperature is creating big changes.
Is global warming happening? No doubt about it. We're living in a warmer world. We're living in a melting world. Sea levels are rising. In this country, in the United States, we live in many areas with great risk to drought, to tornadoes, to hurricanes. And so part of the dialogue is not only extreme weather and global warming, but is the amount of risk we can tolerate.
What is causing our Earth to get warmer? One answer is the greenhouse effect. This phenomenon gets its name because it works like the greenhouses that flowers and plants are grown in. Greenhouses are usually made of glass or plastic and are designed to trap heat. So, when you walk into a greenhouse, even on the coldest day of the year, it is quite warm. As the sun shines into a greenhouse, its thermal energy can't escape through the glass and gets trapped inside. But what do greenhouses have to do with our Earth getting warmer? Gases in the universe form a layer in the atmosphere that acts like a greenhouse. These gases are known as greenhouse gases. The most common one is CO2, or carbon dioxide. Carbon dioxide is emitted from our cars and factories. Another greenhouse gas is CH4, or methane. This gas comes from cows as they digest their food. H2O in gas form is a greenhouse gas, as is N2O, or nitrogen oxide. Nitrogen oxide comes from plants as they die and rot. Here's how greenhouse gases affect the atmosphere. During the day, the sun's rays warm the earth. At night, as the surface of the earth cools, heat is released into the atmosphere. Greenhouse gases work like the glass in a greenhouse and trap this heat near the surface of the earth. They slow the loss of heat. These greenhouse gases in the atmosphere are causing the Earth's temperature to rise over time. Did you know that water is also considered a greenhouse gas? Our atmosphere contains a great deal of water. Some is in gas form, known as water vapor, and some is in the form of liquid. These are clouds. Clouds are tricky. The water in clouds holds some of the heat from the Earth's surface. This prevents some of the sun's heat energy from being released back into space. This would keep heat close to the Earth's surface. But some of the energy from the sun is reflected back into space from the bright white tops of the clouds. So, in this case, clouds help to keep the Earth cooler. Climatologists and other scientists are still trying to understand how much clouds affect the warming and cooling of the Earth. There sure are a lot of factors that determine our weather and climate. Let's review what we have just learned. Question 1. By how much has the Earth's surface temperature risen over the past 100 years? A. 1.5 degrees. B. 5 degrees. C. 10 degrees. D. It hasn't risen. The correct answer is A. The Earth's temperature has risen 1.5 degrees over the past 100 years. Question 2. Which greenhouse gas is emitted by cows as they digest their food? A. CO2. B. CH4. C. H2O. D. None of the above. If you answered B, you know that methane, or CH4, is emitted by cows. Question 3. How do greenhouse gases affect the atmosphere? A. They increase the loss of heat. B. They have no effect on the atmosphere. C. They slow the loss of heat. D. None of the above. The correct answer is C. Greenhouse gases slow the loss of heat in the atmosphere. What role does the ocean play in climate? As we learned, climate is affected by many different factors. One major factor that affects climate are oceans. Remember, our planet has lots of water. In fact, oceans cover 70% of our Earth's surface. They cover a lot of area and in many places are very deep. The average depth of the ocean is 2.7 miles. Our vast oceans play a crucial role in determining weather and climate. Our oceans get thermal energy, or heat, from sunlight. As our planet warms, much of its extra energy is absorbed by and stored in our oceans. Oceans soak up this heat and redistribute it more evenly around the Earth. How do oceans absorb and redistribute heat from the sun? It helps to remember that as water molecules get heated, they turn into water vapor and are exchanged in the air through a process called evaporation. So, our solar-heated oceans are constantly evaporating, which in turn increases the temperature and humidity levels of the surrounding area. Rain and storm clouds form as a result of this process. Winds carry these storms far distances. Almost all the rain that falls over land started over the ocean. The tropical climate zone is particularly rainy because of the higher amounts of heat that are absorbed by the ocean. Outside of the tropics, heat is redistributed through the ocean currents that flow within the water. Currents are created by surface winds, changes in temperature, or unequal heating, the salinity or salt content of the water, the spinning of the earth, and tides. So, the oceans affect climate by carrying heat to different parts of the world. All that heat that is absorbed in the oceans of the tropics is carried by currents up to the North Atlantic Ocean. The cold water of the Atlantic sinks very deep and is spread out around the globe. This cold water is replaced by the warm water moving up from the tropics. Scientists call this process the Great Ocean Conveyor Belt because it keeps the exchange of cold water and warm water constantly moving. Another reason that the water of the North Atlantic sinks so easily is because it is salty. Saltier water is heavier than less salty water. But did you know that when salty water freezes, it can't hold on to its salt? When salt water freezes, the salt mixes with the water below, making it even saltier and heavier. The water of the North Atlantic is very cold and very salty, so it sinks very deep. This keeps the ocean conveyor belt churning. Now we know that oceans play an important role in weather and climate. Let's review what we have just learned. Question 1. How much of the Earth is covered in oceans? A. 15%, B. 30%, C. 55%, D. 70%. If you answered D, you know that 70% of the Earth's surface is covered by oceans. Question 2. What do we call the process by which molecules are heated, turned into water vapor, and exchanged in the air? A. Cooling, B. Photosynthesis, C. Evaporation, D. None of the above. The correct answer is C. This process is called evaporation. Question 3. Outside of the tropic zone, how does the ocean redistribute heat? A. Through currents, B. Through cloud formation, C. Through riptides, D. All of the above. The correct answer is A. Ocean currents redistribute heat. What are the effects of global warming? Earlier, we learned about the greenhouse effect. The greenhouse effect is very important for maintaining the balance that allows for life on Earth. It keeps our temperatures fairly steady and just right for ecosystems. However, since the Industrial Revolution, humans have needed more and more energy for factories and cars. Currently, 80% of the world's energy comes from burning fossil fuels. The burning of these fuels produces huge clouds of carbon dioxide, known as carbon dioxide emissions. These clouds float up to the atmosphere and make the layer of greenhouse gases even thicker. This, in turn, dramatically increases the greenhouse effect and the warmth of the planet. As the Earth is getting warmer and warmer, the global climate is beginning to change. Even though the increase in temperature is small, our delicate ecosystem is greatly affected. As more carbon dioxide is released into the atmosphere, the amount of carbon dioxide in our oceans has increased. This makes the water more acidic. Many sea animals don't like acidic water. Mussels, for example, are less able to make strong shells in acidic water. Coral are also affected because their skeletons are made of the same type of material as mussel shells. Another effect of higher temperatures in our oceans is the melting of sea ice in the Arctic and Greenland. Satellite images have shown that Arctic ice melts and shrinks during the summer. Arctic ice is its smallest size by each September. As winter comes, the ice grows again. However, for the past 30 years, the September ice has been getting smaller and thinner. This ice allows polar bears to travel and seals to make homes to raise their cubs. The shrinking ice areas mean less hunting ground and fewer areas for habitats for many animals. Higher ocean temperatures have also affected frozen rivers known as glaciers. Glaciers flow like rivers, only much more slowly. Higher ocean temperatures have caused glaciers to flow more quickly. This can cause flooding of habitats, forcing animals to find new homes and new hunting grounds. As more glaciers and sea ice melt, the sea level rises. This melting water is not the only cause, however. The higher temperatures are causing the ocean waters to expand. During the past 100 years, the sea level has risen 6.7 inches. Rising sea levels threaten low-lying coastal areas of the world. Places like the Netherlands will be in danger of flooding.
All this stuff we talked about, when you retreat the ice cover and you heat the ocean up with more sunlight, you also have to think about there's going to be more water evaporating to the atmosphere. There's a lot of other exchanges going on. That's going to change the way that the Earth's climate works, and we expect weather patterns over North America to change. Now, this stuff is very, very difficult to model, but the most recent models suggest is that if we lose the Arctic ice cap, we may have more drought in North America. So these are important things for us to learn about and plan for and deal with.
The ecosystem of the Earth is so interconnected. If higher temperatures are causing problems for sea life and rising seawaters threaten coastal areas, it is likely that other species are affected too. Animals that hibernate are also affected by the warmer global temperatures. Some animals, like chipmunks and bears, are waking up more than a month early, and others are not hibernating at all. These animals are then unable to find enough food and are in danger of starving to death. Plant life is affected by climate change too. Pine trees thrive in cold weather. Rising temperatures have made them more likely to become infested with insects that eventually kill them. These pine beetles have killed over half of the pine trees in some forests in the western United States. With so many pine trees gone, the animals of that area are left to find new homes. Global climate change has far-reaching consequences. Let's review what we have learned about global climate change. Question 1. How much of the world's energy comes from burning fossil fuels? A. 20%. B. 50%. C. 60%. D. 80%. The correct answer is D. 80% of the world's energy comes from fossil fuels. Question 2. How does the increase in carbon dioxide in ocean water affect marine life? A. It makes the water more acidic. B. It makes the water cooler. C. It makes the water saltier. D. All of the above. The correct answer is A. CO2 makes ocean water more acidic. Question 3. How are hibernating animals affected by global climate change? A. They have more places to hibernate. B. They have more food to store. C. They wake up earlier and have less food. D. They are not affected by global climate change. If you answered C, you know that global climate change is causing hibernating animals to wake up earlier and have less food. Thinking question. What are some ways we can reduce the emissions of fossil fuels?